Right now, there is an invisible war happening inside the software that powers our world. And it's honestly wild. Attackers aren't just breaking down the front doors of corporate servers anymore.
Right. Yeah, the whole playbook has changed.
Exactly. Instead, they are poisoning the very tools developers use to build the house. They're turning the everyday process of writing code into like a movie plot level heist.
Yeah, the battlefield is completely relocated. I mean, the perimeter isn't the firewall you set up to protect your customer data anymore.
No, not at all.
The perimeter is now the laptop of a junior developer sitting in a coffee shop, just pulling down libraries to make their AI tools work.
Which is terrifying. And our mission today is to figure out how we got here, and more importantly, how these attacks are actually being pulled off. So we're doing a deep dive into three major reports from March and April 2026.
Oh, these reports are eye-opening.
They really are. We've got data from Mick Guardian, a really deep supply chain analysis from Comet, and a highly detailed forensic report from Trend Micro.
Right.
And our goal here is to look at how the AI revolution has basically accidentally created a massive systemic vulnerability in how software is built and how attackers are exploiting it with just terrifying sophistication. So, okay, let's unpack this. We are looking at a fundamentally broken ecosystem where speed has completely blinded us to security.
It has. And to really understand these supply chain heists, we first have to look at the treasure the attackers are hunting for.
Right, what are they actually after?
Well, they aren't looking for credit card numbers or user databases. I mean, at least not directly. They are hunting for hard-coded secrets.
Secrets. So we're talking about like API keys, database passwords, authentication tokens, stuff like that.
Exactly. In modern software architecture, these secrets are the master keys to the kingdom. They're what allow a web app to talk to an Amazon cloud server or, an AI agent to query a private database.
Right, they bypass human login screens entirely.
Yes. So if an attacker gets these keys, they don't have to hack in. They just log in.
They just walk right through the front door. And according to the 2026 Get Guardian report, there is a literal gold rush happening for these keys right now. They call it secret sprawl.
It's an epidemic, honestly.
Yeah, the numbers are just staggering. In 2025 alone, 28.65 million new hard-coded secrets were leaked into public GitHub commits.
Over 28 million. Just think about that volume.
Right. That is a 34% jump from the previous year. It's the largest single-year jump ever recorded. It basically means developers are just pasting their passwords directly into the code they share with the world.
Yeah, and the volume of that sprawl is directly tied to the AI factor. I mean, the barrier to writing code has completely collapsed.
Oh, for sure.
We've moved from, leading edge AI experiments into an era where literally anyone can generate a complex application in an afternoon.
Right. You just ask an AI to build it for you.
Exactly. But because developers and a massive influx of non-developers, by the way, are scaffolding projects at breakneck speeds, they're completely bypassing basic security hygiene.
They just want it to work.
Yeah, they're focused on getting the application to function, not on securing the credentials that actually make it function.
It's like buying a state-of-the-art sports car but totally forgetting to install the brakes.
That is a perfect way to put it.
You know, you're moving incredibly fast, but you are leaving your house keys in the ignition at every stoplight. Like, GitGuardian found that when developers used Anthropic's Claude Code to co-author commits, they leaked secrets at twice the baseline rate of human-only developers in 2025.
Twice the rate. That's just wild.
Yeah, and at its absolute peak, it was hitting 31 leaked secrets per 1,000 commits. The AI is just helping them write the code so fast that they don't even review what they're committing to the public record.
If we connect this to the bigger picture, this isn't just a matter of human error or individual carelessness. It's a structural failure across the industry. Creation velocity is completely outpacing identity maturity.
Yeah.
And it's not just the AI coding assistants causing this, right? It's the infrastructure we use to build AI applications.
The data on that is wild, actually. The connective tissue used to build AI services like Brave Search for web scraping, Firecrawl, and DeFi, they're seeing secret leaks grew 5 times faster than core AI labs like OpenAI.
And that makes sense because an AI agent is utterly useless without context. It needs to read your corporate wiki, it needs to search the web, it needs to access your internal ticketing system.
Right, it needs data.
Exactly. And to give the AI that access, developers have to feed it tokens. Consider the Model Context Protocol, or MCP.
Right, the new standard.
Yeah, it's the new open standard introduced recently for connecting large language models to external data sources.
And MCP exposed over 24,000 unique secrets in its first full year. Which is, well, the reason why is the part that really illustrates the structural failure you're talking about.
Oh, the documentation issue.
Yes. The official documentation for these popular MCP servers literally tells developers to hard code their API keys directly into the configuration file.
It's unbelievable.
It is. It's written right there in the quick start guides. They are prioritizing a friction-free 5-minute onboarding experience over basic fundamental security principles.
It normalizes terrible security practices from day one. And what makes this sprawling mess of credentials truly terrifying is their lifespan.
Oh, right. How long they stay active.
Yeah, Guardian went back and retested secrets they found leaking all the way back in 2022. Now, you would rationally assume that once a company realizes an API key has been exposed on the public internet, they immediately revoke it and issue a new one.
Right. You would hope any security team worth their salt would catch that and shut it down.
You'd hope. But shockingly, 64% of secrets leaked back in 2022 are still perfectly valid right now in 2026.
Wow. Over half of them, 4 years later.
Yes. This happens because companies are terrified of breaking their legacy systems. They don't know exactly how many internal applications depend on that specific API key, so they just leave it active, hoping no one finds it.
Hoping for the best.
Exactly. And this means an attacker doesn't even need to race against the clock. Once a secret is published, it remains a durable, silent access path for years. And this persistent vulnerability is exactly what sets the stage for the next phase of this invisible war. Developer machines and internal environments have just become absolute gold mines.
So we know developers are leaving millions of keys scattered across their local machines, but how do attackers actually get inside those local environments to harvest them?
That's the tricky part.
Right, because they don't hack the machine directly, they poison the tools the developer invites in.
Yes, the supply chain.
Exactly. Big Guardian analyzed data from a massive supply chain attack called Shai-Hulud 2. They found that on an average compromised developer machine, a single live secret is copied in roughly 8 different locations.
8 locations.
Yeah, it's sitting in plain text in their dot files, their IDE caches, their shell profiles. It is a decentralized treasure trove just waiting to be scooped up.
Which leads us directly to how attackers are orchestrating that scoop. They target the foundational infrastructure of the AI ecosystem itself.
Yeah, let's look at the comment report on the LightLLM supply chain attack from March 24, 2026.
This one was huge.
Massive. LightLLM is the gateway layer that nearly every major AI agent framework uses to route requests to different language models. It has 95 million monthly downloads.
Yeah, everyone uses it.
Exactly. Massive platforms like Crew AI, Browser Use, and OPIC all depend on it, and attackers managed to hijack the PyPI account of the LightLM maintainer, which gave them the ability to publish official Python packages.
Right, they looked completely legitimate.
They did. Once they were in, they pushed out 2 malicious versions, 1.82.7 and 1.82.8.
And version 1.82.8 is where the attack mechanics become incredibly sophisticated. They utilized a technique involving a .pth file, specifically naming it littleminute.depth.
Hold on, let me stop you there, because everything I know about malware says someone has to actually click a bad link or run an executable or explicitly import a poison library into their application and hit run. Are you saying the developer didn't even have to run this LightLM package to get infected?
That is the insidious genius of the .pth file technique.
Okay, explain that.
So, in the Python programming language, there is a built-in module called site. Its entire job is to initialize the environment and tell Python where all your installed libraries live.
Right.
As part of that automatic boot-up sequence, the site module aggressively looks for and processes any file ending in .pth inside your site packages directory. And it does this every single time the Python interpreter starts, regardless of what script you were trying to run.
So the developer didn't even need to write an import little statement in their code?
No, not at all. Merely having the compromised package sitting on their hard drive was the trigger.
Wow.
Yeah, if that developer opened their terminal and typed Python to start a completely unrelated script, or typed pytest to run some unit tests, or even ran another pip install command to get a different package, that core startup process automatically executed the attacker's payload hidden inside that .pth file.
That is wild.
It really is. It's a zero-click execution triggered by the victim simply doing their normal job.
Okay, so once that payload triggers, it is a smash and grab of epic proportions.
Oh, absolutely.
The malware runs a massive credential harvest across all the scattered locations we talked about earlier. It looks for AWS credentials, SSH private keys, Kubernetes configs, Docker registry authentications, database passwords. It even looks at your bash shell history to see what commands you've typed recently.
It takes everything.
Everything. It grabs it all, encrypts it with a massive 4096-bit RSA key, and ships it off to a fake domain the attackers registered called models.licham.cloud.
And that encryption choice is highly deliberate, by the way.
Oh.
Yeah, by using a 4096-bit RSA public key hard-coded into the malware, they are using military-grade asymmetric encryption. Only the attackers hold the corresponding private key on their servers.
Oh, I see.
So even if a corporate security team intercepted the network traffic leaving the developer's laptop, they would just see a wall of impenetrable ciphertext. They wouldn't even know which specific secrets had been stolen, which makes incident response a total nightmare.
Because you don't know what to revoke.
Exactly. This raises an important question, though, about how we protect ourselves when the attack comes from inside the house from the package manager itself.
Because honestly, almost every developer out there just types pip install and trusts whatever comes down the pipe.
Right, and the Comet report highlights a crucial defensive divide here. Developers who were using modern lock files tools like Poetry or Iji, they were completely protected.
Okay, why is that?
Because a lock file is a cryptographic manifest. It pins dependencies to exact, verified versions and hashes. It essentially says only install version 1.82.6, no matter what shiny new version is sitting on the server.
Right, it ignores the poisoned updates.
Exactly. But developers who just ran a bare pip install or pip install upgrade were fully exposed because the package manager blindly pulled the newest poisoned version.
And think about how catastrophic this becomes when you look at automated systems like CI/CD pipelines.
Oh, the pipelines, yeah.
Right, these are the automated servers that build, test, and deploy software directly to production. And they often run those unprotected pip install commands on every single build.
They do.
Those pipelines hold the absolute most privileged, highly sensitive credentials of all. They hold the master keys to an organization's entire cloud infrastructure. So if your automated pipeline pulled that poisoned LightLLM package, the attackers didn't just get a developer's local keys, they got the keys to your entire production environment.
The blast radius is just immense. But while that LightLLM attack targeted Python developers building AI, the attackers didn't limit themselves to that ecosystem.
No, they definitely didn't.
They applied these exact same supply chain poisoning tactics to the foundational JavaScript layer of the entire web, and they used anti-forensic techniques that are practically invisible.
Yeah, let's dive into the Axios compromise from the Trend Micro report, because this happened just a week later on March 30, 2026.
Such a short time frame.
Right, and if you thought 95 million downloads for LightLLM was a massive attack surface, Axios has over 100 million weekly downloads.
It's everywhere.
It is the internet's most popular JavaScript HTTP client. If a web app is making a network request, it's probably using Axios. So attackers hijacked the NPM registry account of the lead maintainer. They changed his recovery email to a Proton mail address and manually published malicious versions of Axios versions 1.44.1 and 430.4.
And what is critical to understand here is the security architecture they circumvented.
Yeah, explain that, because they bypassed a lot.
They did. A massive project like Axios usually relies on OIDC, Open-eyed Connect Trusted Publishers. OIDC is a system that cryptographically ties a specific GitHub code repository directly to the NPM registry.
Okay.
It means a human developer doesn't need to hold a password. The automated GitHub Actions pipeline proves its identity and publishes the code automatically. But the attackers bypassed this entirely.
Wow.
They didn't compromise the GitHub source code. There's literally no trace of these malicious versions in the official repository. They used a stolen NPM token to force a manual published directly to the registry, completely sidestepping the secure pipeline.
Here's where it gets really interesting. To deliver the actual malware without raising suspicion in the main Axios code, the attackers added a brand new dependency into the Axios package manifest.
A phantom dependency.
Exactly. It was a package called Plain Crypto.js version 4.2.1. But if you search the actual Axios source code, that crypto package is never actually imported or used. It's what Trend Micro calls a phantom dependency. It exists in the manifest solely to exploit how the NPM package manager works.
It's so clever.
It really is, because when a developer installs Axios, NPM automatically sees this new dependency, downloads it, and then triggers a built-in post-install script. That script executes a single quiet command, node setup.js.
And that setup.js file is an incredibly advanced multi-platform remote access Trojan. The obfuscation architecture they use to hide the malicious intent of this file is brilliant.
Yeah, the Trend Micro report went deep into this.
They did. To a static code analysis scanner, which just reads the text of the code looking for known bad patterns, the file looks like harmless gibberish. They hid all their sensitive system commands in an encoded string array. They used XOR ciphers, which basically scrabble the text using a mathematical operation tied to a specific parsed key.
Meaning the scanner can't read it.
Right, the true command only exists in memory for a fraction of a second. They used base 64 reversals. And to defeat behavioral scanners, they wrapped their platform dispatching logic in an infinite loop that deliberately breaks after exactly one execution.
They are essentially blinding the security tools.
Totally blinding them.
And the payload is highly customized for whatever machine it lands on. Like, if you install this Poison Axios package on a Mac, the malware download a fake Apple daemon. It hides it deep in your system caches under the name com.apple.accountmon, designed to look exactly like a legitimate Apple Activity Monitor background process to anyone skimming their task manager.
So sneaky.
Yeah. And if it lands on a Linux server, it downloads a Python-based Trojan, completely detaches it from the initial installation process, and orphans it to process ID 1.
Right, the indit process.
Yeah, that means even if you realize something is wrong and aggressively kill the terminal window where you ran the install command, the malware keeps running silently in the background.
But the Windows payload demonstrates the highest level of sophistication, in my opinion, because it executes entirely in memory. It is a fileless attack.
Fileless. That's always scary.
Yeah, it locates your local PowerShell executable, copies it to disguise it as the standard Windows terminal, wt.exe, and then uses that disguise process to pull a payload from its command and control server. But it never writes that payload to the hard drive.
It just keeps it in RAM.
Exactly. It executes the malicious code directly inside the computer's RAM. Traditional antivirus software, which operates by scanning the hard drive for malicious files, won't see a thing because there is no file to scan.
It's terrifying, but the cleanup routine is what really shows the caliber of the threat actors we're dealing with here.
Oh, the cleanup is a masterclass.
It is. The malware acts exactly like an elite assassin. Imagine an assassin breaks into a house, completes the job, but before the police can even be called, they literally replace the broken window with perfectly clean glass, vacuum the floor, and vanish.
Leaving no trace.
Exactly. The malware does the exact same thing to the developer's directory. After it launches the payload into memory, it runs a self-destruction sequence. It deletes its own setup.js file. It deletes the malicious package manifest that brought it in. And then it renames a clean, harmless, decoy file swapping package.md to package.json to take its place.
Wow.
Right. By the time the npm installation progress bar reaches 100%, there is zero forensic trace of the infection left in the code directory.
What's fascinating here is the absolute failure of the registry level protections.
Yeah, how did this even get published?
Right? Let's think about the context. Axios is a cornerstone of the internet. Suddenly, a manual publish occurs, initiated by a user account that just had its recovery email changed to an anonymous Proton mail address, completely bypassing the established secure OADC GitHub Actions pipeline.
That's a lot of red flags.
That combination of events should have triggered massive immediate alarms at the registry level. The lack of an OIDC binding on a project of that scale was a glaring red flag, and the system just accepted it.
It just slipped right through the cracks of the registry's defenses.
It did. And it proves that relying solely on static code analysis and registry reputation is no longer enough. We are dealing with fileless, memory-only attacks that actively delete their own evidence before the developer even knows they've been compromised.
So what can security teams even do?
Well, to catch this level of tradecraft, they have to move beyond just scanning code files and repositories. They must actively monitor kernel-level process spawns and rigorously track network egress traffic. They need to see if a newly installed, seemingly benign package is suddenly trying to secretly phone home to an unrecognized server in the background.
Man, we have covered a massive amount of ground today, peeling back the layers of this invisible war. Let's connect the dots here.
Sure.
We are living in this paradoxical, highly dangerous loop right now. On one side, the AI revolution coding assistant's new infrastructure frameworks is allowing developers and non-developers alike to build software at a breakneck speed.
Faster than ever before.
Right. But that incredible unchecked velocity is generating a massive sprawl of vulnerable credentials, API keys, and access tokens, leaving them scattered all over local developer means and configuration files.
And on the other side of that loop, the attackers are fully aware of this exact dynamic. They know that trying to brute force a heavily guarded production server is just a waste of time when the developer's laptop holds all the keys.
Why break down the door when you can just steal the keys?
Exactly. So they are poisoning The exact tools and foundational libraries developers rely on every single day, like LightLLM for routing AI agents or Axios for handling web requests, they are weaponizing the supply chain to bypass the firewall, break into the local environment, and harvest those sprawling credentials.
So, what does this all mean? It means if you are involved in building or deploying software today, relying on cryptographic lock files, actively rotating your secrets, and rigorously securing your automated CI/CD pipelines isn't just a best practice you can put off until next quarter.
No, not at all.
It is literally the only thing keeping you from being collateral damage in a supply chain heist. You have to ping your dependencies to exact hashes, and you have to govern your own human identities, the tokens and keys your AI agents use, just as strictly as you govern your human employees.
The era of the casual, unverified package installation has to end.
Yeah, it really does.
The security perimeter has fundamentally shifted. It isn't just the firewall protecting the database anymore. The perimeter is your package manager, your configuration files, and your automated build pipelines. If you don't secure the tools to build the software, you cannot secure the software itself.
I want to leave you with one finally provocative thought to mull over. We've seen today how AI coding assistants are drastically accelerating the speed at which developers leak valid secrets into public repositories.
Right.
We also know that the next generation of these AI models is constantly scraping and trading on that very same public code to get smarter.
Yeah, feeding the loop.
Exactly. Meanwhile, attackers are fully automating their malware deployments at the registry level, using incredibly complex obfuscation to hide their payloads from security scanners. So, are we rapidly approaching a reality where AI is fighting AI in an invisible cyber war?
That's a scary thought.
Right, where one AI is autonomously generating and hiding malicious code, and another AI is desperately trying to spot it, while human developers are no longer the builders but merely the battlefield. It really makes you look differently at the software that powers our world.
It certainly forces you to question what exactly is running in the background every time you type a command.
It really does. Well, thanks for joining us on this deep dive. Stay vigilant out there.